Okay everyone, this lesson is on geometric sequences as exponential functions. It's found in chapter 7.7 of our textbook on page 438, so please refer there for more details. Earlier in this course we looked at arithmetic sequences. We use a formula, the nth term is equal to a plus n minus 1 times d, where a was the first term, n is a term number, and d was a common difference. And we said a sequence was arithmetic if we were adding or subtracting the same amount each time, and that amount that we're adding or subtracting each time we called a common difference. So that was arithmetic sequences. Another thing to remember from the arithmetic sequences is that if we were to graph the data in the sequence using the term number and the term values, our relationship would be a linear relationship. So arithmetic sequences are linear relationships, and we use this formula, the nth term is equal to a plus n minus 1d. Geometric sequences are similar. First of all, geometric sequences use the formula, the nth term is equal to a times r to the n minus 1. A stands for the first term, and please bear in mind that this first term must not be equal to 0. R is what we call a common ratio. And this common ratio is whatever we are multiplying or dividing by each time. So whatever we are multiplying each time or whatever we are dividing by each time to get the next term in the sequence, that number is called the common ratio. So let's say I gave you this sequence, 256, 128, 64, 32, etc. Is this an arithmetic sequence, a geometric sequence? Yes, it is, because each time I'm dividing by 2 to get the next term in the sequence. Please bear in mind that when we divide by 2 is the same as multiplying by 1/2. So dividing by 2 is the same as multiplying by half. So given these numbers here, 256, 128, 64, and 32, how can I find the common ratio? The common ratio is found by taking any term and dividing it by the previous term. So if I take 128, divide it by the previous term, 256, that's equal to 1/2. If I take 64 and divide it by the previous term, the term that's before it, that's equal to 1/2. So each time the common ratio is multiplying by 1/2, which we said is the same as dividing by 2. Let's look at another example. If I give you the sequence, let's say -6, 12, -24, 48. What is my common ratio? R. Take any term and divide by the previous term. So if I take 12 divided by -6, that's equal to -2. So I'm multiplying by -2. If I take -24 and divide by 12, that's equal to -22. So I'm multiplying each time by -2 to get the next term. So if I wanted to write a formula for the nth term, just as we did with arithmetic sequence, I take the formula for a geometric sequence, which is the nth term is equal to a times r to the n minus 1, and notice that that's a power. So my first term times my common ratio raised to the term number minus 1. So if we plug in the information we have in this example, my formula becomes, the first term was -6, so that's -6 times the common ratio, which we found to be negative 2. So it's negative 2 and then n to the minus 1 power. So the nth term for this geometric sequence is negative 6 times negative 2 to the n minus 1 power. With this formula, I can find the value of any term number. Let's say, for example, I said to you, find the 9th term in this sequence. Then I just simply use a formula and replace n with 9. So the 9th term would become negative 6 times negative 2 to the 9 minus 1, which is negative 6 times negative 2 to the 8th power. And you want to do this part first before you multiply by the negative 6. So that's going to be negative 6, and I think negative 2 to the 8th power is equal to 256. So it's times 256. So my final answer becomes negative 1536. So the 9th term in this geometric sequence is negative 1536. The graph of geometric sequences is going to be exponential. The graph is going to be exponential. So when we did arithmetic sequences, we got straight lines. For geometric sequences, it's going to be an exponential curve, which means your graph is going to, if you have a graph that looks like this, your graph is going to slowly and quickly go like that, or the reverse is possible, where you go decrease like that, depending on what values you're using. So for a geometric sequence, our graph is going to look like an exponential function. So let's quickly recap. 1, a geometric sequence, we use this formula. The nth term is equal to a, the first term, times a common ratio raised to the power of n minus 1. The common ratio r is that number that we are multiplying or dividing by each time to get the next term in the sequence. And to find the common ratio, just take any term and divide it by the previous term. Take any term, divide by the previous term, and that should give you the common ratio r. The final thing I want to point out is that graph of geometric sequences will look like exponential functions. Have fun!